Hi, I'm John Kohler and welcome to This Old Cloud. Today we're going to be talking Nutanix infrastructure as code using Nutanix's Terraform provider. Some of you may know Nutanix offers a wide variety of options for the different workloads and use cases that you can run on top of our platform. More and more, our customers and prospects are asking us on how to drive these use cases through automation. Nutanix is coming to market with two different solutions to this problem for Nutanix AHV. First is Nutanix COM, our Cloud Automation Lifecycle Manager. Is going to be released with version 5.5 of our product. We can discuss that in a different video. The topic of today's video is leveraging Terraform, and specifically Nutanix's Terraform provider, to automate lifecycle management on top of Nutanix AHV. In the 1.0 version of our provider, which is expected to release in around September 2017, we're going to have one resource type, Nutanix Virtual Machine. That's built on top of what we call the Intentful API, or version 3 of our API. Obviously, for those of you familiar with Terraform, know that you don't have to interact directly with the vendor's API while you're doing Intentful specifications inside of Terraform itself. Just know that this is built on top of the V3 API and it's leveraging our Golang SDK. Also know that Nutanix is not releasing this as a one-off. We're going to be upstreaming this, working with HashiCorp and the Terraform community maintainers to bring that provider upstream so that both community members can inspect the source codes that we're releasing, as well as contribute features if they so desire. From a version supported perspective, those of you who have been following Terraform for a while know that they recently split out the provider architecture in between the core distribution and now a new provider's GitHub, which is going to allow them to basically deconstruct their release tracks for the core product as well as the providers that are bringing automation resources to bear. We're going to be releasing with a minimum of version 10.5 and Nutanix AOS 5.5. The reasons driving this on the Nutanix side is the V3 APIs as of 5.12, which is the current shipping GA version, are in a beta state or a tech preview state. That said, we know we're going to use those APIs, so we've leveraged the tech preview API set to bring this to market early. 5.12 APIs are currently based on Prism Element only. When we transition over to the GA version of the provider, we're going to be switching from Prism Element only to Prism Central only. Leveraging the Prism Central approach is going to allow you to automate across your entire estate from a single API endpoint, much like you would with Azure GCP type endpoint. Without further ado, let's talk about where the rubber meets the road. First things first, I'd like to walk through what a sample workflow looks like before we actually cut over to the actual demo to show you what we're doing. The goals here are to provision a VM on Nutanix AHV called This Old Cloud TF Windows. Pretty straightforward for a demo. This virtual machine needs to have 2 vCPU and 2 gigs of RAM. Obviously, we could configure that, but demo is going to be this on the compute side. We're going to leverage Nutanix's image service to pull in a Windows image that we've already built and to provision that out, similar to leveraging a AWS AMI or a GCP image from the repository. We're going to connect this VM to an existing virtual network, and we'll talk about how that works in its entirety. And at the end, we're going to power the VM up. Instead of just jumping right into a fast-moving demo where some sample code executes, let's walk through the pseudocode process on how we'd even build this thing. Well, the first things first, we need to tell Terraform where to go. In Terraform speak, that's defining a provider syntax for Nutanix. And we'll put our Prism credentials there. Second, we're going to define a resource within the Terraform state file called Nutanix Virtual Machine for This Old Cloud TF Windows, the VM that we're talking about provisioning. And third, we're going to define a specification for that VM. Each provider calls this and structures this a little bit differently. In the Nutanix world, it's called an intent spec. And it needs to contain the follow to meet our goals and requirements we talked about earlier. First, we need to have 2 vCPUs. Nutanix supports both the core and socket construct, so we can construct that however the math works. Obviously, 2 vCPUs is pretty easy in this case. Second, we need to have 2 gigs of RAM. Note that the Nutanix API calls for everything in MIB format, so it's 2048 MIB of memory. We're going to provision a virtual NIC with a certain UUID of a network we want to connect to because that network already exists. We're not defining that as part of the Terraform build file in this sample. Next, we want to provision a disk for that virtual machine from an image that already exists. And lastly, and this is kind of a Nutanix specific construct, and you'll see this on other providers, but have some simple metadata for the VM. You'll see this as we do more advanced workflows on what this does, but just note there's going to be a metadata spec as part of this. And lastly, we'll define any additional steps or outputs that we need to, and this is just Terraform BAU or business as usual. So let's get into the actual code that's in the Terraform file here. As a reminder, our pseudocode was define Prism credentials in provider Nutanix. And actual code is this. We've got provider Nutanix defined in this spec at the top of the TF file, and 4 different entities here within that spec. I've got username, password, endpoint, and insecure. Obviously, username and password are pretty self-explanatory. This is our Prism username and password that has previously been defined within the system. You could use admin. Obviously, you don't want to do that from a production perspective, so we've defined a user John here with a super secure password. Endpoint is my Prism virtual IP address. Notably, this is not the data services IP address. This is the Prism VIP for either a Prism Element cluster or a Prism Central cluster, which you'll see in 5.5. Insecure is a Boolean value here to just say that we're using self-signed or untrusted certificates. Obviously, if you were going against a managed service that had signed certificates, or you already had the certificates accepted on the API requester side, you wouldn't have to set this. Next up is the resource spec. As we talked about in the pseudocode, we define a resource and intent spec for the Nutanix virtual machine. So the actual code looks a little like this. Now it's a lot to go through at once. We'll talk about some notables here. We're defining this old cloud as our VM name, both as the Terraform resource name as well as the VM name. Note that those could be different. Sometimes there's use cases for those to be different. And we've got our spec set up here with a description and the resources that we're going to provision with a virtual machine. Now the resources where this gets most interesting. Obviously vCPUs versus sockets is really buyer's choice. This is a typical trade-off of how virtual compute is presented into a VM. Am I doing 2 sockets with multiple cores, or am I doing many sockets with a single core each? Functionally, they work very similar. Memory size, again, is MIB, not MB. So if you need to be spot on, you could have a conversion spec in here to translate from one to the other. Otherwise, you just define it as MIB. This is also how it works in the GUI. Next up is NIC list and disk list. Obviously, these are both arrays, so I could provision multiple NICs or multiple disks, either or, as I so choose. These UUIDs here come from ACLI. They're not resource or data source types that are predefined within Terraform. Future Terraform release, Terraform provider release rather, will have access to those. But in the meantime, we'll talk about how this works. Other future forward-looking things is that if I want to define volume groups, those are actually a separate API endpoint on our side, or I should say a separate API spec on our side. So you'll see that as a separate resource type on the Terraform side in a future provider release. Last thing before we get into the crux of the real demo here is where those UUIDs for network and disk attachment come from. If you're not familiar with the CLI on Nutanix, we have a CLI called ACLI, which is Acropolis CLI, and we require the UUIDs of those resources to attach to when they're defined in the Terraform spec. So you'll see here that if I go into ACLI, which is SSHing to a CVM, hitting ACLI and then typing netlist and image list, I've got some UUIDs here. Now in the future, you could use Terraform data sources or Terraform resource types to, for example, provision a network before you attach something to it, which is a similar type of workflow to how you do it in AWS. So let's get into the real demo and see this in action. All right, so let's get into Prism here. So we've got our credentials that we define in our main TF file. I'm punching them here just to show you what Prism looks like. First things first, you'll see that I'm in high contrast mode. When I logged in, that was the last setting that I've set. I'm going to turn that off for the sake of this demo so it looks a little prettier. But just know that if you're on a projector and want to do a demo, high contrast mode kicks ass. So you'll see on the cluster here, I'm running Nutanix AHV version .84 here. If I go to About Nutanix, I'm running version 5.12, and we called those out earlier in the presentation. You'll see I'll go over to the VM tab here and show you what's existing on the cluster and show you that we don't have this VM that we're about to provision already provisioned in there. So I've typed in TF, it auto-completes, and you see there's no VMs that are called TF. So I'm going to switch over to so now that I'm over on my CLI, you can see I'll punch in Terraform version, show you we're running 10.5. We'll also take a look at that TF file here. You can see it's just as we've talked about in the presentation, where we've got the provider section, the resource section, with the various intent spec defined. We'll pop over into the Nutanix cluster now and do an NCLI cluster info. This is going to show us a variety of data, including a cluster version, an external IP address. This is the endpoint in the Terraform TF file that we saw before. Next thing I'll do here is go into Acropolis CLI, which is ACLI, and do a net list. And you'll see the networks I have configured along with their UUIDs. If I go back into my TF file here, you'll see that I'm also going to bring up the image list here. You'll see that on the net side, my BF11 UUID there matches my dummy network that I've created over on the Nutanix side. And my disk image, 4CF, so on, matches the 4CF on the UUID on image list. And that's a Windows 2012 image that I've configured. So I'll also do a VM.list on ACLI, and you can see towards the bottom of the list, I don't see this old cloud VM here, so there's no tricks being played. I'm now going to go into Terraform plan, and you'll see it's going to reach out to the cluster and say that there's no TF VM there. You'll see what it's going to do. I'll expand out this window a little bit. You can see it's following that TF file spec that we talked about, putting it on the right network, using the right image, and giving it all those resources we talked about. Do a Terraform apply. This will actually go out to the cluster API with the SDK that we talked about and flash this thing down like it would any other Terraform resource. You'll see it took a second to create here. We're not speeding that up, and it outputs the UUID, the name, and the IP address. So it's a .68 IP address. You'll see if I go back in here into ACLI and do another VM list, it'll update on demand. I've got this old cloud VM, and that UUID 4F69 matches the one that I have over on Terraform. If I do a vm.get and do a little tab complete there, I can see the UUID matches. The state is set to on like I asked it to. I've got the 2 vCPUs there configured. I've got my dummy network configured like I did in the TF file. My memory is configured there. My IP address is configured. I've got my little description configured. Beep boop, I'm a VM. This is what it looks like on the Nutanix side. You'll notice the structure is a little different, but the things that we've asked it to do in Terraform are largely the same. So if we go back to Chrome, maximize this here, you'll see it's already updated. Again, we're not playing any tricks on the time here. So you can see the tasks that I've executed from Terraform via the API. If I reduce the zoom here a little bit, you can see a little bit more on the screen. My virtual disks are there. It's booting up. I've got my virtual NIC with that .68 IP address. I've got the tasks that you saw up at the top. They're the VM-specific ones down here. It took about under 3 seconds to get this done. I'll launch the console. This is all HTML5. Just brings it right up. You don't have to install any plugins. Do a Control-Alt-Delete. Punch my credentials in here. And log in. Scroll down a little PowerShell command line and check out the IP configure here, and you'll see that .68 IP address has flowed through to the endpoint. So if I had some other logic in here, it would be connectable. Obviously, this is a dummy network, and you'll see again the UUID is displayed in the GUI just as it is in the CLI and just as it is in Terraform. If I look at the update VM here, you'll see I've got my name, my description, all my resources, my disks, network adapters, and I'm good to go. And that's it for the demo. If you like, please subscribe to get videos in the future. You can comment here on this video in the comment section here on YouTube. I'm also going to post a link to both this presentation and the .tf file that was used in this demo on Dropbox, and I'll put a link here. You can also reach out to me at John Kohler on Twitter. Also note that one of our SMEs, Mark, is going to be at HashiConf this week. So feel free to reach out to him. You can chat about this more in person.